We're introducing ourselves to sequences and the recursive definition of sequences in particular. So you can see we've got two lists of numbers here. 1, 3, 5, 7 and 9 is the first list, and then we've got some fractions listed, and they're examples of sequences. A sequence is basically a list of numbers where the order is important. Okay, the order is quite relevant. So sequences often have a rule that describes them, and the rule can be written in different ways. In everyday English it'd be pretty easy to describe the first one here. So we'd say, in order to write down the terms in the sequence, we start at 1 and we add 2 every time. And we do that as many times as we need to. So the ellipsis points here, ellipsis points mean that basically it's an infinite sequence. Alright, so a sequence is basically a list. It can be finite, or a sequence can be infinite. This one here has a starting value of 1/3, but we're not adding this time as we go from one to the next. This one perhaps requires a bit more thought. So what would be the rule to move from one term to the other? Maybe pause the video and see if you can work it out. We're not adding anything, are we? So we're multiplying by 1/3 each time. And if you multiply 1/3 by 1/3, you get 1/9, and so on. So it is still a sequence. There is a constant, or there is, I won't use the word constant, but there is a consistent rule and a starting point, and that's kind of what makes a sequence a sequence. In general, we call the terms each element in the list. That's a term, that's the next term, that's the next term, etc. That's a term, that's the previous term. And basically, T sub n, I should say, T sub n is the general term. In a sequence. Basically, n is a positive integer, is usually the case. So n is basically a counting number. So we would call this the nth term. T sub n is the nth term. So what a useful thing would be is to go from one term to the next. So some terms you add, and they would be written as this, like the first example you see there. So that would be a case of that. So we could call that case 1. The other case we saw was like this. So it's a different situation. So to get the general term, we're not adding, are we? We have to do something different. Alright, in the second case, we are to get from one term to the next, we basically get the previous term and multiply it by 1/3 and you get the next term. Or to get the term you're after, get the previous term and multiply it by 1/3. So that basically is a constant multiplier. So I'm just putting in general there, so that gets replaced by a symbol, some value a. We often give these names. D is called common difference, so it stays as D for the whole sequence. Common difference, it's the difference between one term and the next. It doesn't help to think of difference in terms of subtraction in this way, because we're adding it on. And the A here is a common ratio, but we are multiplying. These two types of terms have specific names. This one is called an arithmetic sequence, and this one's called a geometric sequence, arithmetic and geometric. So writing it like this would be called the recursive definition or the recursive formula for an arithmetic sequence. So that's based on the recursive definition, so this is called the recursive formula for an arithmetic sequence. This one is also a recursive formula for the geometric sequence. Recursive means going from one to the next. Again, recursive is defining something by going from one to the next in the sequence. So from one term to the next term. Like we saw in the example, for the recursive formula we need the first term, and we need the rule. Later on we see, in fact, we can get away with not knowing the first term if we use another approach, but for this basic approach we need the first term or a term and we need the rule. The other way of writing the formula for an arithmetic or geometric sequence is in terms of n. We can write it. So I just have here again the same sequences as we started with before. So looking at how do you write it in terms of n, which is the number of terms or the term number, we could write the first one there as this. T sub n equals 2n minus 1. That involves n, so that's contrasted to the other way of writing it, the recursive way, which would be T sub n equals T sub n minus 1 plus 2, because the common difference here is 2, going from one to the next. But if we double, let's say we want to find the fifth term, and means we double 5 and take 1. Let's check that out. So we double 5, take 1, 2 by 5 is 10, take 1 is 9, and 1, 2, 3, 4, 5, fifth term is 9, so yes, it works. So we'll look at ways of coming up with that formula in terms of n in a future video. With the second sequence, the geometric sequence, before we said to get from one term to the next, we basically multiply the previous term by 1/3. So to use n in terms of n, we would have to write this here. If you have a look at it, the first term is 1/3. Okay, it's 1 over 3 to the 1. The second term is 1/9, which is 1 over 3 squared. So n equals 2. N equals 3 on the third term, 1 over 3 cubed. And on the fourth term, n equals 4, 1 over 3 to the power 4. So there's two main ways of writing a sequence, whether it's arithmetic or geometric.